The instrument went quiet on August 25, 2012. Voyager 1's plasma wave detector had tracked the roar of the solar wind for 35 years. Then the roar stopped. Density spiked. The old model said this should happen once, at a clean boundary, and never again. Mission scientists called it the Heliopause, the edge of the sun's bubble, humanity's first spacecraft in interstellar space. For a few years, the case looked closed. It wasn't closed. It had barely opened. The heliopause was supposed to be a wall, a single, sharp transition, where the solar wind runs out of pressure and the interstellar medium takes over. Cross it once, and the data should settle into a new, stable regime. Voyager 1's early readings seemed to confirm exactly that. Then the cosmic ray counts shifted again. Not once, repeatedly. Magnetic field rotations showed up that a simple wall couldn't produce. The plasma oscillated in bursts, triggered by solar storms that had left the sun years earlier and were only now slamming into the boundary from behind. The first explanation was contamination, instrument drift, aging hardware, 40-year-old electronics returning noisy signal. That explanation almost worked. Voyager 1 is old. Its power source is fading. Some of the anomalies really were instrumental. But Voyager 2 broke that explanation. A second spacecraft, a different trajectory, a different instrument suite, still functioning cleanly. It crossed the heliopause at a different distance, and it measured a different internal structure entirely. Two working spacecraft don't independently invent the same impossible boundary by accident. The boundary wasn't standing still. It was breathing with the sun's 11-year activity cycle, swelling when solar wind pressure rose, shrinking when it fell. This is where the case stops being about two spacecraft. If the heliopause moves, then every model of how much galactic cosmic radiation reaches the inner solar system across geological time needs revision. That radiation shapes atmospheric chemistry. It may shape habitability itself, on this planet and on any star system whose stellar wind bubble weakens on a similar rhythm. Three explanations compete for what's actually out there. The boring one, solar cycle pressure alone pushes the boundary in and out, like a bubble losing and regaining air, and everything else is measurement noise from two aging instruments. The physical one, the interstellar wind pressing against the heliosphere, isn't even. It hits softly on one side and hard on the other. That asymmetry bends the boundary into a bulge on the upwind face and drags a long heliotail out behind it, not a comet shape, but something closer to a deflated croissant, folded and irregular. The frontier one. The boundary isn't one structure but layered regions. Membranes stacked with different plasma properties, and Voyager 1 and Voyager 2 each cut through different layers depending on the angle of their exit. If true, the textbook diagram of a smooth teardrop bubble is wrong at a structural level, not just a cosmetic one. The case isn't closed, and the limits are real. Two spacecraft can't map a three-dimensional boundary. Each one gives a single trajectory through a structure that may vary enormously with direction. The instruments are decades old. Power is falling, and within years, the spacecraft will stop transmitting entirely. Whatever shape the heliosphere actually has, humanity may only ever sample two thin slices of it. A future test exists, but it isn't fast. A dedicated interstellar probe, built from launch to map the boundary from multiple angles, could resolve the crescent versus croissant question within a couple of decades of transit time. Until then, the magnetic reconstructions are models built from two lonely data trails. The dangerous temptation is to say the mystery is solved because the spacecraft crossed a line. The data doesn't support a line. It supports a shifting, asymmetric, multi-layered membrane that responds to the sun's own heartbeat. If this is the kind of cosmic file you want followed, Subscribe. The next observation may be stranger than this one. The honest question is which model should carry the burden of proof? The simple pulsing bubble that needs only solar cycle pressure, or the layered, asymmetric structure that needs data no probe has gathered yet? Voyager 1 is still transmitting, faintly, from beyond the boundary it was supposed to have already crossed for good. The edge of the solar system was never where the diagram said it was. It was never where the last measurement said it was either.